Okay, cool. So Java, similar syntax and control and data structures to C and C++, but it's a little bit more higher level. So it's imperative, it's object-oriented. It was originally designed for interactive television, which when I was looking over the slides, I thought it meant like you could like participate in like the TV shows and the movies, but it's way less boring than that. It just means that the TV set box that's on top of your TV, it allows you to interact with that with things such as like a television remote. So it was mainly built for that, but then found success in initial early applications on the internet, and it is now sort of a general purpose programming language. So similar to Python, C, C++, it's part of like the Mount Rushmore of very good programming languages, and it currently enjoys widespread acceptance. Now, the thing about Java and the thing about this class in general is that it's very important to start thinking about things in terms of objects. So we're going to run through a little bit of an example here. I'm not going to use a chalkboard because I value my hearing and my ears, but let's say that we're building a program that's going to be in charge of collecting tickets or a ticket service where you can buy and sell tickets to OSU football games. Does anybody have any examples of what objects we might want to include in that program? So you can think of, I'll start, we might want a ticket object that represents the tickets to the specific games. And that ticket might have an attribute called a price, or it might have a string, which tells you which game it is, OSU versus Michigan. What are some other objects you might think about? Yeah.
Maybe they can be objects for passes.
Yeah. So if you're talking about like viewing the stats within the game, you might have a pass. And what's an example of like an attribute that a pass might have?
Maybe like price. Like I was thinking like the big packages where like either it's like the Big Ten or like.
Oh, okay. Sorry. I thought you meant pass, like a football pass for a second there.
No, yeah.
Okay, yeah.
I was thinking like the packages could be a different object, and then like
Right.
the price could be an attribute for that.
Yeah, exactly. Like that. Okay. What are some other examples? Yeah, you in the back.
Maybe a seat.
A seat? Yeah. So
Yeah.
what might a seat have?
A number.
Exactly. Cool. Another attribute. What are some other ones? Yeah. Exactly. Yeah. So if you want your user to be able to actually interact with the program and have different, you don't want my ticket getting mixed up with your ticket. So each user would be unique. So what might you have as like a user? Username, account balance. Perfect. Yeah. All these are good answers. Let's get one more. Oh no, I overstood my welcome. No more, no more. Going once. Who said that? What was that? Wait, sorry, can you speak up? Time? Okay. So like in what sense? Okay, cool. That might actually be an attribute of like a game object. So let's say you had like a game that represented OSU versus Michigan or Michigan State versus Rutgers. An attribute of that game might be a time. So it's important to think about everything in terms of objects, because you can imagine, we talked about on Tuesday, the Undertale example, where you just throw everything in one main method of code. And let's say, for example, you have your ticket object and tickets start at $50, but you also have your user object, and the user can be a fan of a certain team. And let's say if the user is a fan of Michigan, you want to jack the price of tickets by like 700% or something like that. If you have all of your code in one main method, you're first going to have to dig through all of that code in order to figure out how the user object works, how the ticket pricing object works, and then you're going to have to go through and fix the code. Whereas if you have everything stored in these objects, which have attributes and methods, it's very easy to pick apart the different classes and change things one at a time. We all good on classes and why it's important to think of things as objects. Once we get into some examples of the objects that we use in Java, or specifically in CSE 2221, you'll understand a little bit more about what I mean. Okay, now we're going to go into a little bit of Java compilation. So Java, the main reason that it was able to get such widespread acceptance is that it was able to be run on a lot of different machines. And the way that it's able to do this is through the Java compiler. So what it does is it checks the source code of a program in a Java file. So you can think of that like your hello world or your template.java file example. And if there are no compile time errors, it generates bytecode for that program and saves it in a class file. So this is like when you're going through and you're programming your first program or your Hello World program and you forget a semicolon on the end of the line, it automatically starts yelling at you. This is because in real time, Java is constantly compiling your Java file into these intermittent .class files. And if there are any syntax errors, like missing a semicolon at the end of a statement, then it'll start yelling at you. So once you actually go to run the program, it does this one final time and compiles it down into a .class file. This stuff also doesn't get tested on, but it's just good to know as background. Then we have what's known as a Java virtual machine, which runs on sort of like a physical chip, like hardware, or on an operating system like Windows. And this allows you to run any Java program. This is what allows you to, let's say I wrote a program on my Windows and then I send it over to somebody who has a Mac. You're still able to run it because of the Java virtual machine. It loads the .class files, the things that get compiled from these .java files, and then executes it by interpreting that bytecode. And this is all part of the Java runtime environment, which is just the Goliath of Oracle that they have that runs on pretty much any PC, which makes it so widespread. So you'll see a lot of web applications are built off of Java and JavaScript because everybody pretty much has Java. So here's the example that they give you is myprogram.java. And this is, say, your Hello World program or your Hello Jack program that you're going to be writing tomorrow. And once you're ready to compile it, your code is perfect. You've read it through maybe once. The Java compiler generates bytecode, legal, though not necessarily correct program source code. So just because your Java program is legal, it doesn't have any syntax errors, that doesn't mean it's correct. Like if I assigned you guys an essay on the history of Java, and one of you guys submitted like a perfectly written, no syntax errors, no grammar mistakes essay on like, I don't know, the history of chalk as it pertains to the US economy. Like technically, like you submitted an essay, it was very legal, but it was about chalk and not the history of Java. And so it would be wrong. That's where you get into different types of errors other than syntax. So your myprogram.java file gets compiled down into a .class file. And then this .class file is sort of the magic sauce that's able to run on pretty much any device that you have. The launcher loads JVM in your bytecode, which JVM executes by interpreting it. And this is just the full picture here, is you have your .java file, gets broken down into the .class file, gets read by the JVM, which is on top of the hardware OS. And here's the magic sauce. The same bytecode can be run on other hardware OS with its own JVM. So run once, deploy anywhere, I think is the Java slogan. JVM is ubiquitous. It's a big word. I don't really know what that means. Widespread, exactly. So JVM is widespread. JVM is present, appearing, or found everywhere. So yeah, anywhere you look, any website that you go to, most programs, a lot of programs you'll see will be written in Java. Universality, program source code need not be in Java, so you can compile other languages down into .class files. I don't know why you would want to do this. Usually if you're writing in Java, you want to deploy it in Java. And then the extra layer of the JVM, instead of just running it on the higher hardware OS or configuring the hardware OS to read the .class files, it's got a surprisingly small penalty in performance. So yeah, that is the boring history of Java that I must go over. Does anybody have any questions on this? Yeah. No. Yeah, I'm not going to be like, what was Java originally used for? No. It's just to give you sort of background as to stuff. Yeah, cool. So now we get into arguably the more interesting stuff, which is actually beginning to talk about CSE 2221, and we start with output, strings, and input. So yeah, I'm going to grab a sip of water. I'm going to jump into it. Okay. So how many of you have seen this before? Okay, even if you have, we're going to break it down and go part by part. So this is the absolute simplest Java program. What these 3 lines of code, I guess, do is print out the word hello, or the words hello world to the console. So we're going to start with a public class hello world. This defines a class called hello world, which is of these objects types that I talked about before. So you have your tickets, you have your football teams. You might also have a class called hello world. And this is essentially, this rings bells in the Java interpreter to say, hey, I'm making a public class. It's called hello world. When I compile this code, I want you to make bytecode for this. Hello world is the name of the class. Details later. It says that a lot, details later. Another thing I want to go over now, because I don't think it's ever duly mentioned, is this public keyword. So when you're generating classes, a lot of times you'll have to put a keyword in front of it. So class is what tells the compiler that I want to make bytecode out of this. I want to convert this .java file. Make sure you have a bytecode for this hello world class. Hello world is the name of the class. That public identifier is what tells the other parts of the program whether or not it can interact with it. And one thing you'll learn about me is I'm a huge fan of really terrible examples. So I have a really terrible example for you guys. Let's say that instead of being a CSE professor, I decided to go into a different business. And I decided to open up a restaurant called the KrustyKrab.exe, which is a virtual version of the Krusty Krab, where I can sell virtual patties and stuff like that. One thing I might want is a cook here, although I guess SpongeBob's technically should. Pretend that's SpongeBob up there. I might have a cook, and that cook might be a class for the Krusty Krab program, and that might have a method called make burger. So whenever you call that make burger function, it's going to, as you might assume, make a burger. And if you've seen SpongeBob, you know that in order to make a burger, you have to use the Krabby Patty secret formula. Now, this is not good for me. I'm smiling over there. That's me, by the way. But I'm not happy, because if this is a normal Java program, I don't want the user to interface with this make burger function, because then the user would be able to read the function, or the user would be able to extract information from the function and obtain the secret formula. Enter our antagonist, Plankton. I would not want the customer to be able to interact with the cook or any of the cook's methods, including make burger, because that make burger method is using my secret formula. So in this instance, I might want the cook class to be private. And what that essentially means is that none of the other classes are able to access any of the methods or attributes of that class. So Plankton would not be able to extract the secret formula from the make burger function. Does that make sense? Yeah. Yes. You can still instantiate it, but you can't, certain parts of the program won't be able to call it, basically. And this is one of the object-oriented design principles. This is what I'm talking about, like everything, you have to think about everything in terms of objects. You also have to think about it in terms of which parts of the code do I want to reveal to other parts of the code. So in this case, I would not want the customer class to be able to have access to any of the cook's methods. Does that make sense? Okay, cool. Any other questions about that? Okay, awesome. That's the first really bad example of the semester. Don't worry, there will be like at least one more, because there's another one later today. Okay, public class hello world. Break it down. Next up, we have a public static void, and this is a method. So let's break it down again. Public, again, we just talked about that, where it defines who is able to use that method. So public means that pretty much anyone can use that method. Static means that you want, static is a non-changing, it's kind of irrelevant in this class, but essentially it means that it doesn't change. Void means that it won't return anything. So if you had public static int main, then you would be telling the person that's writing this method, at the end of this method, I would like to return an integer from this function. So void basically says at the end of this, I don't need anything from this function. It's simply a void method. Got kind of a dark name, void, but I don't need anything at the end of this method. And then the main is what tells the computer that this is a main program. And anytime that this program is run on the Java virtual machine, main is a keyword, meaning you can't have a separate function called main, because main is like the big guy in charge, like the head honcho. He's Mr. Krabs is main, essentially is what I'm saying. And anytime you run a program on the Java virtual machine, it will go to the main method and it'll just start running. So again, let's go back to Undertale. This is what every single line of code in Undertale was thrown in. And so when you launch Undertale, you click play on Steam. What it's doing is it's going to line 1. In this case, it's just print line hello world. But in Undertale's case, it was the entire game. And it's going to run that program. It must be called main. String args, we'll get into this a little bit later, but functions that you have can take in parameters. And string args is essentially modifications that you can make to the main function. So if you guys remember when we were setting up lab yesterday, there was a part in the instructions where it asked you to add and enable assertions to the Java arguments. What that's essentially doing is it's passing in an argument to this main function. And this can be useful for a variety of different things. Let's say instead of like a main method, this was a square root method. Well, the square root of what? That's why you would want to pass in an argument. So in that case, it might be an integer that you're passing into the function. But in this case, it has a string, which is an array of however many arguments you might want to add to the main program. So these are modifications or special things that you can pass into the program before the program starts. Cool. We all good on that? Sick. And then now we have this. So system.out.println. So system.out, like we've been talking about today, is an object that you can use to give output to the user. Println is a method of that object, and then you can call or invoke that to output something on its own line. And so now we're going to talk about the second very terrible example of the day. You can think, oh, shoot, I got to go through everything. You can think about system objects or system.out.println. Instead of system, let's say we had a person object. We were building a program that was going to run a bunch of simulations on the Earth. Instead of out, we had a mouth method. So this mouth method might have a bunch of functions like eat. It might have a bunch of functions like brush teeth, stuff like that. But in this case, instead of print line, it can be sort of like shout. So you have your upper level, which is your system. This is pretty much the entire system of Java. It's sort of just a general use case for things you might want to call. And then you have out. This is an object which describes sort of the output stream of the user, whether that be to a text file or whether that be to the console. You can think of this like a person's mouth. And then println is a method which allows you to output text to whatever output stream you have. Similarly, shouting is a way that you can output text to whatever output stream you're using, in this case, your mouth. We all good on this? Cool. No more bad examples for the rest of the day. I apologize. So yeah. Hello world is a character string that can be used as the output. You can think of this like how when you're deciding what to say, you're essentially passing in arguments to your mouth in order to make it talk. In the same way, when you're calling system.out.println, you're telling the system, hey, give me your output stream, and then print this to the console or a file, which we'll talk about later. And hello world is just what we want to output. Okay, so most of you guys have seen the basic hello world program. This is how you would do that same thing using the custom OSU CSE components. So this is sort of vanilla Java, and this is how you would do it using our custom OSU CSE components. I know I talked about how OSU does things a little bit differently. This is how you do it. So the import statements up at the top are what actually gets the OSU CSE components into your program. Sometimes you'll have an error where it says that simple writer was not found. The package simple writer was not found. And this is because you haven't imported it into your program. I like to think, actually, sorry, another bad example. I like to think of this as like DLC in like a video game. You plug it into your game and it gives you extra functionality. So let's say if you were writing a Java program and you needed a bunch of math functions like square root or stuff that wasn't in the base version of Java, and you didn't want to write a square root method by yourself because you're lazy, like I am, you can import a math.squareroot function. So there's extra functionality that you can import into Java. And in this case, the extra functionality is the Java OSU CSE components. So you have the upper level, which is components, which takes in a bunch of different Java OSU CSE components. So components has a stack, components has a queue, components has a set. In this case, we want the simple writer, and we want both the overarching simple writer class and then the simple writer 1L. And we'll get into the difference between the two a little bit later, but essentially simple writer 1L is a version of simple writer. So sorry, another example here. You can think of simple writer as car, and you can think of simple writer 1L as Ferrari. So simple writer is going to have a lot of overarching things that you might want out of a simple writer, and simple writer 1L is going to have a little bit of custom functionality. So a car is going to have a lot of general stuff that you might want in a car. Like it might have a drive function, or it might have a honk the horn function. And a Ferrari might have a function that's like gun it 90 down the highway. And that would be specific because you can't do that in like a 2002 Ford Escape, which is what I drive. Well, you could, but I don't think I would survive. Cool. We all good on packages? Yeah. Yeah, exactly. So instead of there's also a simple writer 2, and there's also like a simple writer 1, maybe. There's a bunch of different versions of simple writer that you can import. You can also do like, I'm gonna use the chalk, everyone brace yourself. That actually wasn't that bad. If you do import components.simplewriter.star, that's basically telling the program import everything from the components.simplewriter family. So yeah.
Does OSU not encourage using templates?
That's a great question, actually. I think it does. But for whatever reason, the classes, I think we go over it in one of the later lectures, but I'm not going to be too like, as long as you're not like, I use my own version of Campbell case where every other letter is capitalized. So you just can't read the program. Generally Campbell case is accepted. What he's talking about is how you would name like functions or variables. So let's say I had a function called, I'm so sorry. Let's say we had a function called gun it, which means like you're gonna like gun it down the highway. This is like in like a, okay, that's actually like, okay. In this case, this is like a car. I'll add this. Haha, guys. You know what? I'm not using this stupid pen thing. All right, so this is our car function. Don't worry about that. I'll pick it up later. Somebody remind me to pick that up. I'll forget. And you had a function called gun it down the highway. Actually, let's make it longer so you can. Oh, holy. So it's called camel case because you only capitalize after the first word and it kind of follows a camel's humps. There are other ways to do it. So you could have a function. A lot of people like to use underscores. So might be like that. Should have picked a shorter word. I'm going to be honest. Some people like to do that. Some people like to capitalize every word in their function names or their variable names. I'm not going to force you guys to pick one. Personally, I use camel case just because it makes it a lot easier to read. You can imagine if all these letters were lowercase. I'm not going to write it out again because I'm lazy. But If everything was lowercase, it'd be hard to understand what the function name was. But yeah, does that answer your question? Sorry, I was
Yes.
long-winded tangent there. Okay, any other questions about packages?
In the same vein, would you be able to put like components dot star and you get?
Yes, I believe so, yeah. Yep, and you'll see packages in pretty much every language. Python is a big one. You can't really do anything in Python without importing packages. Yeah. Question? System? It might be. Oh, you mean like system.out. So no, that's built into Java, so you don't have to import it. There's some stuff that is like built into Java that you don't have to import, but since these components are custom OSU CSE components, you have to import them into your program. Does that make sense? Cool. Yeah.
I'm still a bit confused about what system is. A system in an object, or is that just referring to the entire Java language as a whole?
So system is an object that represents sort of your computer. So that's how I like to think about it, at least. System sort of just represents your entire computer. Out is the output stream for that computer in reference to Java. So you can't do like system.shut down my computer, I don't think. It's only pertaining to like Java in your IDE. There's UI libraries that we'll talk about. And then you can do system.exit, which like shuts down the program. It's a way of controlling things in your program. Does that help a little bit?
Yeah, so essentially an object referring to your computer.
Yeah, in relation to Java. You won't need to know too much about system. I personally am lying to you. I don't know too much about system. I just know that there's system.out and system.in, and those control like the input and the output streams of the computer. Cool.
When you import stuff like components, like where is it looking? Is it looking like local storage? Is it finding it online? Like where is it finding it?
Yes. I believe when you downloaded, I forget the name of it, but the components.jar, that's a file which contains all of the OSU CSE components, and then you added it to some class path variable or something in Java. You modified a sentence or modified a setting that said point towards components.jar. That was specifying it so that you can actually import them. So if you had like a custom package that you wanted to import, you would download that version of the .jar, and then you would add that to the setting, similar to how you did with components.jar, and then you could import it correctly.
You're referring to the last one.
Yep. Yeah, components.jar.
Will we use a rates later in this class, or you have to import Java.util, or is it included in some way?
I want to say it's included. And luckily there's no like custom OSU CSE array. They let you just use like normal vanilla arrays, which is awesome. All right. Any other questions about packages? Good questions, guys. Means I don't have to like waffle for like longer to extend the class time. It's awesome. Okay. Public means anyone that can use this class. If you think back to the Krabby Patty example that we talked about, awesome Krabby Patty example. Public versus private talks about who can use the class. Final means that no one can incrementally change this class by using inheritance. Inheritance is another thing that you want to talk about. We'll be talking about later, but essentially it means that when somebody instantiates a class as Hello World, it is a Hello World class and nobody can change it or modify it in any way. There are reasons that we'll talk about in the future where if you have one version of a class, you might want to change it to another version of the class, but that's a little bit later. And this final keyword, as another aside, you'll want to use this when you're declaring constants. So let's say you're writing a program and you want to use pi. I'm going to erase this. This eraser kind of sucks. Some teacher's going to come in here and see the remains of Gun It Down the Highway and be very confused. Okay. So let's say you're writing a program and you want an integer which represents what's like a constant. Actually, let's just do pi. So pi is not going to change. So you might have final double. Double is a way that you can represent floating point integers. And then you have pi equals 3.14. This is so later in the program, pi cannot be changed because pi is a mathematical constant. So you don't want to change it throughout your program. That's what this final keyword does. So yeah, you'll want to do that a lot with constants and things that aren't going to change throughout your program. And that's a way that you can use final with like primitive type integers. All right, private hello world means that the hello world class does not define a type, i.e. no one can create an object from the hello world class because it is a utility class. More details later, but essentially this means that nobody can create an instance of the hello world class. If you were making a car class, you would not want the car to be public or private because you want people to instantiate versions of cars. What good is a car if you can't have one, right? On the contrary, I don't think anybody's missing out by not being able to have a hello world object in their program. But we'll talk about utility classes a little bit later on. And now we get into simple writer. So simple writer is going to be a variable that defines an output stream. So similar to, you can think of simple writer as system.out. It is basically, for all intents and purposes, the same thing. The only difference is that we're putting it in an object called simple writer. So we have simple writer out equals new simple writer 1L. What this is essentially telling the computer is, hey, I want a simple writer, a sort of class that lets you output things to either a console or a file. I want it to be called out. That's the name. And I want it to be of type simple writer 1L. The best example that I can come up with this is simple writer, like I talked about, is the overarching class, and simple writer 1L is a specific type of class. So if I walked into the car dealership, I wouldn't just say like, hello, I would like car. Please give me car. Like, I would have to go in and I would have to say like, hey, can I please have a Ferrari, or can I please have a Mazda? That's how it works with simple writer 1L. You have to specify the type of simple writer that you want. Does that make sense? Cool. So we're saying, hey, I would like a simple writer. I would like a car. I would like it to be called out. I would like it to be called whatever your name car is. And I would like it to be of type simple writer 1L. And I would like it to be a Ferrari or Mazda. There's your next bad example for you. New creates a new object, which the variable out is a reference to. Simple writer 1L is a class whose code should be used when any method of out is called. And we'll talk about that later. When we talk about reference types versus primitive types, we actually talk about that later as well. But the only thing you need to remember from that is simple writer 1L is an object similar to how we were talking about earlier, the ticket class or the player class or the user class. Out has a print line method too, nearly identical to that of system.out. You could use system.out.println. Actually, you can't. OSU forces you to use, not forces, strongly encourages to use the out.println. And it's essentially the same as system.out, like we were talking about earlier. It defines an output stream and it has a print line method that allows you to print things to either the console or a text file, which we'll see a little bit later. The only difference is that out also has a close method as well that you need to call. So when you, see if I can get the code here. When you define a new simple writer object and you call it out, you're opening that output stream. So you're saying, I'm going to be putting text through this output stream, either to the console or the file. And simple writer makes you close that output stream at the end of the function. So when you're done outputting things to either the console or a text file, you have to close the output stream. And that's what it's doing there. All right. Simple writer also allows you to output things to both the console and the text file. So this is pretty much exactly the same, except when you're defining something that you want to go to an output file, you simply just include the name of the text file that you would like to output text to. So this one right here is specified only for console output. So anytime you call console out.println, hey, I'd like to print something, it's going to go to the console. And anytime you use file out.println, it's going to print it out to this foo.text. And I believe if the text file is not made, it will make it for you, but I'd have to double check with you on that. And it's also path dependent. So if you have a Java class, and then you make your own folder called like output text files because you want to keep everything organized, you would have to specify that in the output path. That's a path variable. So in that case, you would have to do like output text files / foo.text. Does that make sense? Cool. And here are some examples of output. So you have console out.print prompt. This will print out the words prompt to your console. The difference between print and print line. So print is going to print something to a line and not go to the next line, whereas print line will basically just serve as you hitting enter on your keyboard. So if I had a function that just had a bunch of prints, and it was print A, print B, print C, print D, print E, print F, it would go like this. And it would all be on the same line. But as soon as you call print line, and let's say I had a bunch of print line functions or method or print line function calls, and it was A, B, C, D, E, F, instead it would be A, B, C, D, E, F.
So that's like if you put A, B, C, D, E, F all in like one, like you wrote console out that print LF
Mhm.
line, and you wrote A, B, C, D, E, F like all in one line. And
Yep.
It would print it like six.
It would print it like the first one. Exactly. Yeah. So it just doesn't go to the next line. And there are ways that that's useful. So in this case, let's say you're prompting the user for an integer. It might just be more aesthetically pleasing if you have prompt and then you have the integer on the same line, so that if they're going back and they're looking at their code, they can see that they entered in 4. Whereas if it's on the next line, it's a little bit uglier. I don't know. There are ways that it's useful. And then in this case, file out.println prints out a line to a file. So it's not going to appear on the console, but let's say that our file was named foo.text. I don't know what it was about this pen that made the chalk so terrible, but it would print out a line. And same thing here, where if you use print line, it will go to the next line. Whereas if you just do print, any print statement that you have following that will be on the same line. With wraparound, of course, because it's a text file. Cool. And then when you're done writing output to a simple writer stream, you must close the stream. So console.out.close and fileout.close. Yeah. Any questions on file streams? Or are we good there? Very simple, or very similar to scanners. If you've used scanners in Java before, it's just OSU's version of scanners. All right. Java has special features to deal with character strings. When they mean character strings, they just mean strings. OSU just likes to call them character strings. So this, actually, what do you guys think that this would do? Can somebody describe what this text or what this code would do? Yes.
On the second one, so it's kind of telling that you're adding something new. Title concept.
Yeah. So what would the output of this program be? Let's say this was stuck in like a main method.
Just like it just prints out, and then later on it prints out the file out. Of what is said over there.
Yes, but where does that hi Mr. Foo text go?
Like in the
Yeah, in the foo.text document. So we would have a file called foo.text, and on it would be hi Mr. Foo. Sick. And yeah, foo.text is just a character string. And hi, Mr. Foo is also a character string. All right, so character string contents are also called string literals, and they're always enclosed in double quotes. So this hello world thing is just in single quotes. They can be concatenated, so you can have hello space and then plus world. One thing you have to be wary about is that it doesn't automatically add a space in there for you. So you can see it's added here, but if you didn't have this and then you concatenated them together, it would be hello world with no space in between. So you do a lot of concatenating of strings, so it's very important to remember that you have to add spaces in there. You can declare a string variable and assign it with initial character string value as follows. So here we have a string cheer, which is equal to go. This is actually a very important thing to remember is when we're talking about variables, strings are reference types, which means I'll just go over very quickly the difference between reference types and primitive types. So string is a reference type, which means instead of containing an actual value, it contains a reference to where that value is stored. So we have our string cheer here. And instead of like an integer, which I'll call A, in which A might contain the integer 4, instead of just containing the string go, it's going to contain a pointer to another box, and that's going to be where it actually contains the string go. It's not too important right now, but starting to think about the different types of variables and how they're referenced, integers being a primitive type, meaning it's stored directly there, and strings being a reference type, which means it stores a reference to something else, is going to help a lot when we start talking about custom objects. So we have this string, yeah.
So could that be like if you had like an error, like if statements or something, if you have an error message that's like constantly like, if they do this error, if they do this error.
Yeah.
If you put like string error equals like, you know, quotations you messed up, and then you could just do like out dot and print like
Error, yeah. So if you had, if you wanted to like define it and you thought that the message wouldn't change, you could say like final string error message equals you messed up. And then anytime there's an error in the program, you could just say out.println error message. And what it'll do is it'll say, okay, error message, what is that? On the computer, I'm going to go here and I'm going to print out whatever is stored at the reference type. Cool. And then you can assign any other character string value to the same variable later. So in this case, before the assignment, what we have is we have this cheer variable, which points to go, and we're saying take that cheer variable and add space bucks to it. So who can tell me what the output of this line of code will be? Yes, exactly. So what the computer's doing is it's saying, okay, give me whatever's in Go. That's the first part. And I'm just going to concatenate this space bucks here. So space bucks. And then it's saying, put that back into the cheer bucket or wherever cheer is storing the variable. I'm not going to put that in there because it doesn't fit, but yeah. Okay, so similar to the fact that we have simple writer, we also have simple reader, and it can do the same thing. It can take text input from the keyboard and it can take text input from the file. In the same way, you have to specify the type of simple reader. So simple reader 1L in this case. But simple reader is the overarching class that allows you to get input from the user, whether that be from the console or whether that be from a file. And similar to simple writer, you have to specify the name of the file that you want to read from if you're reading from a file. So here's some examples. String line equals keyboard in dot next line. What that will do is it will get all of the input for a particular user up until a certain line. So let's say I say, hey, enter your name, and I put Steven. What it's going to do is it's going to store whatever the user types into the keyboard into that line variable. So it's saying, here's the line of the program, put a box around it, set it equal to line. And now it's just a string variable like any other string variable you might have. And then you can get the next line by saying line equals file in dot next line. So this would be like Sammy. It's my roommate. What that's saying is forget what we have in line. Get whatever's in the next line and then store that in line instead. So this is how you can get like constant input from the user by using the same simple reader. This method, which reads up through including the next line separator. So yeah, at the end of every text string, so like if you're typing in your name, what it actually has is it has this -n, I believe, which is like a carriage return. And it's not shown when you're typing things, but it signifies the end of a string. So it's going to go until it hits that carriage return. This is like if you're if you have a program and it's like, please type the entirety of the Declaration of Independence. Obviously, it's going to spill over to next lines because the Declaration of Independence is long, but as long as it doesn't have a carriage return, it'll all be stored in the same string. All right, and then you have to close the input stream and the output stream. Or sorry, you have to close the input stream similar to the way that you close the output stream. Okay, cool. We're doing good on time. Does anybody have any questions about anything that we talked about today? Or any of the labs, projects? Yes.
Oh, that,
Yes.
we're working on that tomorrow.
Yep. Yeah.
That's
So
not
that's
a-
like, oh, what's up?
It's not.
No, that is, you will be walked through it through tomorrow's lab and it'll be like the output of, it's the only time that you ever have to submit anything for a lab. And it's not graded, so. Yes.
Like shorts and like spots or just doubles.
No, I don't think we get into using shorts and bytes. Systems 1 you do, and they make you memorize how many bytes each one is stored in, and it's terrible. So you have that to look forward to. Any other questions? Going once. Going twice. Okay, 4 minutes early. You guys can get out of here. Oh, thank you. I actually did forget about that. Yeah. Yeah, for sure. Have a good one.
Me too.